Welcome back, and we're going to keep working with applications. One thing before I start this example that you see on the screen, I do want to just point out that in your textbook they do some very nice explanations of linear costs, revenue, and profit, and you may find those useful. I would recommend reviewing those on your own time. Okay, but anyway, example time. So here we have age and systolic blood pressure for a sample of 12 randomly selected healthy adults, blah, blah, blah. And we're going to let X represent the age of an adult and Y represent the systolic BP. Okay? And systolic BP is measured in millimeters mercury. Okay? So we want to use the points blah, blah, blah to write the linear function where y is a function of x. Okay, so if I use the points to construct a line, this is old hat stuff. Okay, so for part A, I would say, okay, well, we need to find the slope, so then I do 130 minus 118 over 51 minus 21, and so I get 12 over 30, which is the same as 2/5. Okay, so then consequently, I can say that y minus 118 is equal to 2/5 times 20, or x minus 21. Let's get that fixed here. X minus 21, and so then technically when it says write a function, we have to isolate y. So this is good, but we can make it better. So then once I isolate y, you can verify this on your own. I get 2/5 x plus 126.4. So then I would just replace y with f of x. Okay, and that would be my answer for part A. Okay. For part B, it says interpret the meaning of the slope. Okay, in the context of this problem, so I would just say this is for every 1 unit or 1 year increase. Because I'm in a context, I can include the units. 1 year increase in age. The systolic blood pressure, BP, increases by 2/5 millimeters mercury. Okay? Alright, and then for part C it says, what meaning, if any, does the vertical intercept have in this context? So the vertical intercept is this 126.4. So that would mean, it would be the systolic blood pressure of a 0-year-old, which doesn't really make sense. So yeah, which doesn't really make sense. You could say it's the systolic BP of a newborn, which I don't know. This part you could omit. I'll just finish my sentence there. Okay, here we go. Then part D, it says estimate the systolic blood pressure for a 40-year-old. Okay, so again, this is kind of what we've done in the previous videos. We would say, okay, let's find f of 40. So then this is going to be 2/5 of 40 plus 126.4. And if you do this out, I got 142.4 millimeters mercury. Okay, so again, in context, I would say a 40-year-old would have a systolic blood pressure, I'm abbreviating here, of 142.4 millimeters mercury. Okay. So again, when you're in a context, remember to respond in a context or conclude in context. Okay. Now part E, it says investigate the data using scatterplot and least squares regression model. Whoa, what in the world is this? Okay, this we're going to do this in Excel. You'll see me do it here. We are going to kind of just introduce you to the idea, and then you'll do a more formal investigation in stats when you take that. Okay. What we're going to do is we need to make sure to transfer all this data that we're given into a spreadsheet software. Now, the spreadsheet software that the math faculty recommend is Excel. Okay, so you do have a free copy of Microsoft Office to install on your computers. I recommend doing that. If you have questions, we can help you, or you can go to IT and ask them, I need Microsoft Office. Boom, they'll help. Okay, so I've copied everything into Excel. If you want to follow along, please do pause me, repeat me, whatever you need to do. Okay. All right, so with the data in Excel, how we get a scatter plot is we need to select all the data. Okay, and then in Excel there's this menu up top, and you're going to click on Insert, and this is the same in Google Sheets too if you want to use that. And then there's in the Insert tab in the ribbon there in Charts, there's a scatter plot. It looks like a bunch of dots, and then you have different options. We're just going to do the first one to get a bunch of dots there. Okay, and so what we can see is the dots appear, and now the graph is kind of plain and naked, so I'd like to, give it some decoration, some clothing. Okay, so what I want you to do is, with it selected, sometimes there's a little plus here, it doesn't show up for me right now, but with the chart selected, make sure you're in the Design tab, and then go to Add Chart Element, and then Add Axis Titles. And it looks like you have to do them one at a time. So add both the primary vertical and primary horizontal. And then just for our own purposes, I'm going to label them as age on the X, because that's the X according to the problem. And then along the vertical, I'm going to label that as systolic blood pressure. Okay. And we won't worry about a title for the overall chart right now, just because of time purposes, and we aren't going to be submitting this. But you would normally include that. So with the scatter plot, it asks, it just says investigate. So does this roughly look linear? And I'd say, yeah, it looks pretty linear, right? It kind of follows a line. So then it says a least squares regression model. Now, what a least squares regression model is, let me go back here and just kind of draw you a little picture here. So we, in parts A through D, we made one line that could possibly work for the data set, but what we could see, go on, is if our data set looks something like this, and I don't care about axes right now, but we have, something like this. What a least squares regression model is it's going to find a line, okay? And I didn't, let me draw it a little bit better. It's going to find a line, something like that, okay? Such that when we look at the vertical deviations here, so let's call this just the vertical deviations, we can represent it as change in y. So we can do change in y1, change in y2, and that would be another one, change in y3, that's very tiny. And then there would be larger ones like this. This would be change in y4. This least squares regression line is going to minimize the vertical squared deviation. So you'd square the you'd take the deviation squared, and you would find this line is the one that minimizes those. That's the idea. We don't do any of the math. We have Excel does all that math for us. But if you're interested in Calc 1, actually, it's a great problem for a Calc 1 student to do. You can find this least squares regression line using just calculus. Okay. All right. That aside, to find that least squares regression line in Excel, all you have to do is go to Add Chart Element, and it calls it a trend line, which irritates me a little bit, but we're going to go with it. Trend line, and do a linear trend line. Okay, and then with that trend line, you can double click on it, and then there's going to be a sidebar that pops up, and then down below it says there's a lot of options. All I want to do is say display equation. Okay, and boom, there you go. That's the equation of your least squares regression line for this one. So here you have your y, which is systolic blood pressure, is equal to this times x, age, plus your vertical intercept. Boom. Okay, and then typically I'd say, just compare this to what you got from the original model, and you're going to notice the slope's different, the intercept's different, so it's very different. So the line that you construct using two random points may or may not be relatively close to the least squares regression line. Okay. So again, watch this video, or the pieces of it, if you need to remember how to do a scatter plot or a least squares regression line, and then we'll get a little bit more practice with this in class.